In this video, we're going to look at sketching exponential graphs. So that's learning outcome E3. So the first example is sketch the graph of y equals 2 to the power of x. Okay, so if we're not familiar with the shape of a graph, it's sometimes useful to do a little table of values. So in this one, we're going to be sketching y equals 2 to the power of x. And when I say a table of values, we could put a range of values of x into a table and work out the values of y. So when we're doing a sketch like this, maybe it would be useful to look at certain values around 0. So let's just say -3, -2, -1, 0, 1, 2, and 3. And I think that should be sufficient really to give us an idea of the shape of this particular graph. So y equals 2 to the power of x. So 2 to the power of -3 would be, we could do it on the calculator if we like, 2 to the power of -3. It's going to be minus 1 over 8, or say 1 over 8, so it's a small quantity. 1 over 8 or 0.125. So we get 1 over 8, which we know is 0.125. 2 to the power minus 2, it's the same as 1 over 2 squared is 1 over 4, or 0.25. 2 to the power of minus 1 is 1 over 2. 2 to the power of 0 is 1, and 2 to the power of 1 is 2, 4, and 8. Okay, so in sketching this, this will give us the idea of the shape of the curve. So let me just do my y-axis first. And my x-axis, I need to show -3 all the way across to +3 and beyond. So we'll just say 1, 2, 3, and -2, -2, -3, and so on. So I'm going up on my y-axis up as far as, at least up as far as 8. So I think the important thing is, let's see, 2, 1, 2, 3, 4, 5, 6, 7, 8 is way up at the top of my 5, 6, 7. So 8 is right up at the top of the graph. So we call this 1. So this is an important point when x is 0, y is 1. When x is -1, y is a half. And we get closer and closer. For up here and 8 up here. So what we have in effect is a curve that is exponentially increasing, and the curve will never touch the x-axis. It will always be above the x-axis, and we call this curve, it's approaching negative infinity. We call it asymptote because it's approaching the x-axis but never quite getting to the x-axis. Okay, so let's look at the next example, and the next example is, this time we're going to sketch a curve of y equals e to the power of x. And in a similar way, we're going to take a look at a range of values in a table. So here we're going to, and I'll just skip down, we're going to have a table that shows values. We're looking for y equals e to the power of x, and our table is going to show a range of values for x. We're going to maybe calculate for x a range of values from, say, -3, -2, -1, 0, 1, 2, and 3 in a similar way to the previous example. So y. E to the power of 0 is 1. And just bring up the calculator on this one. So we're going to have e to the power of 1 gives me 2. Now we'll do 3 significant figures again, so 2.72, and we'll go back to the calculator and do e to the power of 2. Oops, just delete the 1 and put in the 2, and we'll get 7.39. And then back to the calculator, and we'll edit it back to get the e to the power of 3 is 20.085, so 20.1. And we go to the negative side now. I'll just change the 3 to -3, and that's going to be minus 0.049. Or sorry, it's positive 0.49. 0.049 is a tiny value, and let's go back to the calculator, just fill in the 2 more to fill in. So e to the power minus 2, e to the power minus 2 is going to give me 0.135, so I'll round that to 0. Well, it is 3 significant figures, 135, so 0.135. And then on my table, the last value I need now is e to the power of -1, and just edit on the calculator the value we had. So e to the power -1 will give me 0.3678, so we'll just call that 0.368. Okay, so we're going to use these values to sketch the curve y equals e to the power of x. So I'm just going to look at my y-axis. Now I'm going to be going from y, I'll need from 0 to up to about 20. So I'll make the y-axis kind of long. There's my y-axis, and my x-axis. Again, all these values are in the positive y region. E to the power of x will never be negative. So let's look at my x-axis down here. Undo that. And my x-axis will start from -3 across to +3. Now, because it's an exponential curve, I do in fact know the shape of this curve. It'll be similar to the last one that we did, 2 to the power of x. So I'm just going to draw the shape and mark in a few of the points we found after the fact. So again, this will be asymptote to the x-axis, and it will be increasing and increasing in an exponential fashion. It crosses the y-axis where at the point 0, 1, and I'll mark in just some of the points then. If we'll call that 1, 2, 3, and up there on the 3 we have the 20.1, just to give you an idea of the shape of this curve. Now my representation isn't very accurate, but it gives you a fair good idea of what e to the power of x looks like. So I'll just go on the minus x side. We can just maybe mark one of them in. That's 0. It should be -1 and 0.36. Okay, so I've just marked a few points. So that's sufficient really to sketch y equals e to the x. Let's take a look at the next example we're going to sketch. In this case, we're going to sketch y equals e to the -x. And I'll go back to the pad. Now I'm going to scroll down a little bit, but not too far, because I think we can use the table that we had for the last example. So here we want to draw I want to sketch y equals e to the -x. And again, if you weren't familiar with this curve, a quick table will help work out some of the values that will give you an idea of the shape of the curve. So let's do that now. Um, we'll have a range of values of x and work out the equivalent y for each x. So in this table we have x minus 3, minus 2, minus 1, 0, 1, 2, 3, and y. Now the reason I left the other table up there was because the previous table was y equals e to the power of x. So if we now have e to the power of minus x, I can actually say for x equal to negative 3, I'm going to copy e to the power of 3 from the previous table. So 20.1, 7.39, 7.4, 2.7, and again the crosses the y-intercept is when y equals 1, 0.37, 0.12, and finally 0.049. So in fact this curve is it's symmetrically, it's a reflection, it's a mirror opposite of the previous one. If we consider the y-axis as a mirror, it reflects in the y-axis to compare to the previous one. I'll just draw the axis now and sketch that in. So there's my y-axis, and let's look at my x-axis maybe down here. And e to the minus x will be similar to the previous one, but just dropping in the opposite direction. Again, asymptote to the x-axis, so approaching positive infinity, but never quite getting there. We've x, we've y, and I'll just mark in the y-intercept. So that is a reasonable sketch of the e to the minus x. Okay, so that's it for this video. Thanks for watching, and thank you.